Hey guys, today I'm going to teach you how to add, subtract, multiply, and divide in scientific notation. By the end of this lesson, you'll be able to perform all operations in scientific notation. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's start with adding and subtracting with scientific notation. The first step to add numbers written in scientific notation is that the numbers have to have the same power of 10. If the numbers have the same power of 10, you can just add or subtract the rational numbers out front and then keep that same power of 10. Let me give you an example. Down here looking at number 1, what I mean by same powers of 10 is I know that this is times 10 to the 8th. This one says times 10 to the 8th. They have the same base 10 to the power of 8. So what I can do is I can just add these numbers here underlined green. When I add decimals without a calculator, I line them up vertically along the decimal, and then I just add straight up and down. So 2 plus 3 is 5, and 6 plus 2 is 8. So 8.5 is my answer times 10 to the 8th. So I'm looking at my instructions. If they're the same, add or subtract the numbers out front, and then keep that power of 10. So in this case, the power of 10 is 10 to the 8th power. However, if they're different powers of 10, like they are here on the back on number 7, 8, 9, and 10, then because of the place value, if they're not the same power of 10, you can choose to rewrite one of the numbers. This will give it the same power of 10. So I can't add or subtract unless the powers of 10 are the same. Because remember that times 10 to the power of moves the decimal. It has to do with that place value. So I can't do that until they're the same. I can't add those numbers out front until the 10s match. So look at this problem here on the back with me. Look at number 7. I want to make sure that we can get this right. So right now, the base 10s do not match. This is 10 to the 7th, and this is 10 to the 6th. I need them to match, so I'm just going to pick one of them. I'll just pick this one, and I'm going to make it to the 7th power. So we do that by moving the decimal just one more time. So instead of just 3.4, I'm going to go back one to make that 10 to the 7th power. So I'm going to go back one. So usually we see this exponent that's positive, and that means move the decimal forward to write it out. But what I want to do is make it match this one. So I've got to go back one to make it match. And I kind of get confused with this, just to be honest with you. I kind of get confused why this is a 7, and I wanted how I moved it. Do I move it left or do I move it right? So what I just did quickly to check is I typed in this number in the calculator, 3.4 times 10 to the 6th. It gave me a standard form answer. It gave me this big long number. And then I typed this in the calculator. If this number it comes out with gives me this number it comes out with, I know that these are the same thing and I moved it the right way. So the point of moving the decimal and rewriting the exponent is to get these to match. I wanted to match this base 10 with an exponent of 7 with this base 10 with an exponent of 7. So now that they are, I can go ahead and just bring it down and add like normal. When I'm adding in scientific notation, when they're the same base 10, I'm just going to add the numbers out front. When I did that, I got 5.04. This number is already correctly written in scientific notation because this number is between 1 and 10. So I keep it the same and keep the times 10 to the 7th power. This is my final answer. So I'm showing you how to do these without a calculator because you might not always get a calculator on these. You might also not always get addition problems. Sometimes you might get subtraction problems. But subtracting in scientific notation is the same way. And again, this is without a calculator because this is a quick and easy way to do this. Instead of typing all this out, I know that these are the same base 10, 10 to the negative third, 10 to the negative third power. So I can keep those and just subtract 9 minus 4. So 9 minus 4 is 5, and then keep the times 10 to the power of negative 3. And that's it. That's all you got to do. So when they're in the same base 10, same exponent, you can add or subtract the numbers out front like normal. Just pay attention to your signs. And remember that this base 10 does not change. You're only adding and subtracting the numbers out front. So let's look on the back at another example at number 8. I have 9 minus 8, but I also have a 10 to the 5th power minus 10 to the 4th power. So I know a lot of people are going to do this, and I can see it coming a mile away. They're going to write this. And you know what the mistake that they did? They did 9 minus 8, and they did this little exponent, minus 4. This is wrong. Don't do this. You can only subtract the exponents whenever they're being divided. So don't subtract the exponents. When we're adding and subtracting in scientific notation, that's a mistake I see all the time. What you want to do instead is get these two base 10s to have the same exponent. You want their exponents to match. So I'm going to do that by just picking one of them. I'll just pick 8 times 10 to the 4th, and I'm going to move the decimal back one. It's in front of the 8, so I'm going to move it back one, so that's 0.8 times 10 to the 5th. Again, I have a hard time trying to remember if the decimal goes forward or backwards, so what I do is I type this in the calculator, or I can write it out, move the decimal 4 times over, and I get 80,000. I also can type this in the calculator and I'd also get 80,000. That's how I know that I'm right. So remember, I'm doing this so that I can make these base 10 values match. I need this to be 10 to the fifth. I need this to be 10 to the fifth. And this is a shortcut without the calculator. So I keep the sign the same between them. And now that they match, I can bring down this 9 times 10 to the fifth. When I'm adding and subtracting in scientific notation, then I can just add or subtract the numbers out front. So 9 minus 0.8, or 8 tenths. I got 8.2, or 8 and 2 tenths, and then I just keep that times 10 to the fifth. You want to keep the base. You want to keep the base 10 and the exponent. So if you didn't like that, there's one other way to do it. If you didn't like that shortcut and you don't want to use the calculator, or you're not allowed to use the calculator, the other thing you can do is convert the values to standard notation and then rewrite in scientific notation at the end. So if that didn't work for you, let's try this last way. So let's try that with number 3. So obviously when you look at this, the easiest way to do this for me would be to just do 1.9 plus 5.42 and keep it written in scientific notation. But if you don't like that, you can always convert them into standard notation and then add like normal. So you can take this 1.9, always rewrite, and then I'll move the decimal back 5 times. I move it to the left because it's a -5. So I go 1, 2, 3, 4, 5, and then I just add placeholder zeros. So I did that pretty quickly, and I put them between the little humps here. And I did it kind of ugly, so I see a lot of y'all did this too, and you want to rewrite it. You want to rewrite it underneath of it with 4 zeros, 1, 9. And then we can do the same thing to this 5.42. We rewrite it underneath. It's got a -5, so we move the decimal back 5 times. 1, 2, 3, 4, 5, and then add placeholder zeros. So it should look like this. Then I'm going to rewrite it so that I can add and subtract with this other number. I rewrote it so that it was all lined up on the decimal. And then I have this 2 floating over nothing, so I can add placeholder zeros. Then I just add straight up and down. You can try this by yourself and then press play when you're ready to check. So go ahead and pause now. Okay, so I got 0.0000732. We want to write it in scientific notation. So if you haven't already, go ahead and pause the video and then put that in scientific notation. Okay, so you should now have tried that already. You put the decimal between the first 2 significant digits to make a number between 1 and 10, and then you times by 10 to the -5th power, because that's how many times you moved it. So that was another way to do it. To me, it's just longer. Writing it in standard form and then adding like that is longer, and I wouldn't do it, but I want to show you just in case the first way didn't work out for you. But if they're already in the same base 10, you can just add like normal. 5.42 plus 1.9 gave you 7.32 without having to do all that work. You also don't need to type it out in the calculator, especially if it's too long for the calculator to register. So what I want you to do before I move on is to have you try 4, 5, and 6 by yourself. Go ahead and try each of those problems by pausing the video, and then you're going to press play, and I'm just going to show you the answers. Okay, so you should have just paused the video. You should have just tried all these on your own, and now I'm going to show you the answers. Here's what I got for 4, 5, and 6. If you got something different, please let me know. If you have any questions about how I got these, try to work them out by yourself first. Try to fix what you got, and then you can come and ask me. We'll do the same thing for number 9 and 10. Go ahead and try it by yourself, making sure that they have the same base 10 value before you add these and then subtract these. So pay attention to your sign, pay attention to your base 10, pause the video, and then press play when you're ready to check. Okay, so you should have just tried these 2 problems on your own or with a partner. Now I'm going to give you the answer, and I want you to try it again if you got it wrong. So here are the answers. If you aren't sure what you did different or did wrong from mine, I want you to make sure you check it again, and then you come and ask me. And then here's 4 extra challenge problems. If you want to try those, you can. I'm not going to go over them in this video, but you can try these and then let me know whenever you're ready to check those. So that was a speedy review of addition and subtraction. Now let's move on to multiplication and division. So there's different rules for multiplying and dividing than there were for adding and subtracting. So make sure that you're on the same page with me, and please pay attention. This is really important. To multiply and divide in scientific notation, you want to rearrange the problem, and then you can use your laws of exponents that we should already have learned. For example, you could end up with a problem like this on a no calculator part of a test. If that was going to be the case, you have a strategy. You can break apart 4.5 and you can times that by 2. So you're just timesing the numbers out front, or multiplying the numbers out front. The second thing you could do is multiply the 10 base with an exponent of 5 times the 10 base with an exponent of 3. We should know 4.5 times 2. If you have $4.50 times 2, you have $9 in total. You should also know that if you have 5 tens times 3 more tens, you have 8 tens in total here. So if you multiply exponents that have the same base, you can add the exponents. So I know that this is 10 to the 8th power. So when they're being multiplied, I can combine the exponents. When they were being added, I can't, because this is like 5 tens and then 3 more tens. So there's 10 in total. So now your final answer is 9 times 10 to the 8th power. Sorry, that was ugly. So that's how I'd write it. So the final answer is 9 times 10 to the 8th power. So see how long and hard this problem looked, and it was kind of scary looking? If you break it apart and rearrange the order of things, multiply the numbers like normal, and then multiply the bases with exponent rules, you get an answer pretty quickly. Let's practice that with problem number 1 here. So you have two numbers written in scientific notation next to each other in parentheses. That means to multiply. When two things are written next to each other in parentheses, we know to multiply. So take a second, pause the video if you need to, and rearrange these values so that way the numbers are together and the base 10s are together. So this is how I did it. So I want to put my numbers out front together, 3 times 7.2. I can do that pretty quickly. I know that that answer is 21.6. And then I can also do this pretty quickly. I have a 10 4 times and a 10 2 times. So altogether, I have a 10 6 times. If you aren't sure how I got that, this is an example of the product rule. Go back and check out the product rule. When you have the same base, you can add the exponents. When the same base is being multiplied, you can add the exponents. Keep that 10 base. However, this is not your final answer. And you can pause the video now to think of why. This is not your final answer. It has to do with the decimal. You should have thought to yourself, why isn't this the final answer? Because this number needs to be between 1 and 10. So you have to move that decimal to get it in scientific notation. Scientific notation means that this number needs to be between 1 and 10. So I have to move that decimal back 1. If I move the decimal back 1, that also changes my exponent. If I moved it back 1, I'm going to change that to 10 to the 7th power. This is my final answer in scientific notation. And then just to make sure you understand how to convert from scientific notation to standard form, this next part is asking you to move that decimal 7 times to the right. When you do that, you get 21,600,000. So these are the same numbers, just written in different forms. Before we move on to division, why don't you go ahead and try number 2 by yourself. So pause the video, practice this by yourself, and then press play when you're ready to check. Seriously, pause the video. Give it pause it. Now pause it and try this. Okay, so we want to start by following the directions that we have up here written. So to multiply in scientific notation, we're going to rearrange the multiplication problem. So if you're given a problem like this, you want to put the numbers out front together. So we'll do the same thing here. We'll put 1.5 and 5 out together. So 1.5 times 5 will go out front. You can rearrange this because of the commutative property. The commutative property says that the order doesn't matter whenever you're multiplying. So since it's all multiplication, I can rearrange this because of the commutative property. So I can also put these 10s together. So I have 10 to the 5th times 10 to the 3rd. If you notice too, I put a dot instead of a times. So you can do that. Remember, a dot and a little x mean the same thing in multiplication. So what I want to do is I want to multiply 1.5 times 5. If 5 people have $1.50, altogether, we have $7.50. I know that's already written in scientific notation because it's a number between 1 and 10. So I can write that down here on this line. The next thing that I can do is look at these base 10 values. Know that this is 5 tens being multiplied with 3 other 10s. So altogether, there are 8 tens being multiplied. So your final answer is 7.5 times 10 to the 8th power. To convert this to standard form, I would rewrite this by taking my finger or my pencil, putting it on the decimal. And then I go over 1, 2, 3, 4, 5, 6, 7, 8 times. When I did that, I got 750 million. So it's a lot easier and shorter to write this as the numbers get bigger. And trust me, if this was a 10, a 12, a 50, sometimes we have really, really big numbers, it would be a lot easier to write it in scientific notation than it would be to write it in standard form. That's why we use scientific notation. So now let's look at division. This is the last operation we're going to look at today. It says to divide values in scientific notation, we're going to rearrange the division problem again and apply the laws of exponents again. So this time we need to review our quotient rule. So for this one that you see here, this example, you have an 8 divided by 4, so we can do 8 divided by 4. And you can also do 10 to the 6th divided by 10 to the 3rd. When you break it apart like that, you don't need to type this whole thing in the calculator and make a mistake because you know that 8 divided by 4 is just 2. And you know that if two numbers are being divided, they have the same base, you can subtract the exponents. So the same base here, the base 10, is being divided. You can subtract the number of their exponents. So 6 minus 3 is 3. So your final answer is 2 times 10 to the 3rd power. If you did want to use your calculator to solve this problem, I would encourage you to use parentheses. This on the top should have a parentheses around it, then divided by this with the parentheses around it. If you type this in the calculator without the parentheses, you'll get the wrong answer. So parentheses around the top, parentheses around the bottom. So if you're using a calculator, you have to use parentheses. So you can try number 3 if you want to. I'll go ahead and do number 3 for you, and then you're going to try number 4 by yourself. So let's look at number 3. You want to rewrite the problem. You want to separate 9 divided by 3 first. Then you want to separate 10 to the 9th divided by 10 to the 7th. So you can do 9 divided by 3. That's just 3. And then you can do your quotient rule here, which means that if they have the same base being divided, I can subtract the exponents. So 9 minus 7 is 2. So 3 times 10 squared is your final answer for this question. To write this in standard form, you want to move the decimal over 2 times. It's right here right now. So you go 1, 2 over, and you end up with 300. Number 4 is a little bit harder, but I believe that you can do it. So go ahead and press pause on the video and press play when you're ready to check. Okay, so you should have just looked at this, started out by separating 9.45 divided by 2.1, and you should have separated the 10 to the 7th divided by 10 squared. If you did not have a calculator, you would write this as 2.1 divided by 9.45. You would divide like normal and then put the decimal in at the end. So 21 goes into 94 how many times? Goes in 4 times evenly, and you'd move on from there. No matter how you do it, whether you do it long division or with a calculator, you should end up with the answer 4.5. You know that this is an example of your quotient rule. Because you have the same base being divided, you can subtract the exponents. So you can do 7 minus 2 is 3. So 4.5 times 10 to the 5th power is your final answer in scientific notation. In standard form, that's 450,000. All right, guys, that's it. If you made it to the end of this video, please put 3 words to describe yourself in the comments. Today we went over adding, subtracting, multiplying, and dividing in scientific notation. So now you should be able to perform all those operations in scientific notation and standard form. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!